Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today, the first lesson, force and motion. The first point in the first lesson is momentum. Momentum means the product of mass and velocity of a body, or the product of the object mass and its velocity. Then momentum equal mass times the change in velocity. Mass is measured by kilogram, velocity is measured by meter per second. Then the unit of measuring momentum is kilogram meter per second, or by another way, kilogram meter second negative 1. Then the dimensional formula is MLT negative 1. Momentum is a vector quantity, as is the product of a scalar quantity and the vector quantity. Scalar times vector equal vector quantity. This means that the mass is inversely proportional to velocity. As the mass increases, the velocity of the object decreases, and as the mass of the object decreases, the velocity of the object increases. By comparing the momentum of two bodies, then m1 over m2 equal v2 divided by v1. يعني m1 divided m2 equal m2 divided v1, or by another way, m1 v1 for the first body equal to m2 v2 as a linear equation, the same equation. Then the graphical representation that represents the relation between mass and 1 over v, as it is inversely proportional, is represented as the following graph, where the slope equal delta y divided delta x. Delta y represents the mass, delta x represents 1 over v. Then m over 1 over v equal m times v. m times v equal momentum, layer b. So, as an example, in the opposite figure, which body is or has the large momentum, where the relation between mass and velocity, the body A, body B, and the body C. We know that the slope of this graph equal momentum, and the slope equal tan theta, Then, by increasing the angle, the slope increase. Then, by increasing the angle, the slope increase. Then, which body has the large angle? The body A is more than the body B, more than the body C. Then we say that the momentum of body A is more than the body B, more than the momentum of body C. Momentum is directly proportional to the mass. Momentum is directly proportional to the mass. As the mass of the object increases, the momentum increases, and the inertia increases. Inertia that is related to Newton's first law. And as the velocity of the object increases, the momentum increases. The relation between them is directly proportional, and when the momentum increases, when the velocity increases, the momentum increases. That is also directly proportional to inertia, and the inertia is the tendency of the body to keep its state of rest or of motion. Example, for comparing the momentum of two bodies. From the figure, find the velocity of the second pole. First pole of mass 5 kilogram and the velocity 6 meter per second. Second pole of velocity 3 kilogram and unknown velocity. Then, since in m1 divided m2 equal v2 divided v1, by substitution the number in the relation, then 5 divided by 3 equal v2 divided by 6, cross multiplication, then v2 equal 5 times 6 divided by 3, then the velocity of the second body equal 10 meter per second. This is the first point. Newton's second law. The second point in this lesson is Newton's second law, and the Newton's second law is verified by two different definitions. The first definition, the resultant force acting on a body equal the rate of a change of momentum. The resultant force acts on a body equal the rate of a change of momentum. The rate of a change of means divided by time. Then the resultant force sigma F equal the rate of a change of momentum. The resultant force sigma F equal the rate of a change of momentum. Momentum equal m dot delta V divided by t, and delta V divided by T equal acceleration. Then the mathematical relation for Newton's second law, sigma F equal m dot A. The mass is measured by kilogram, acceleration is measured by meter per second square, or the unit is equivalent to Newton. Then the force has two measuring units, kilogram meter per second square or Newton. Kilogram meter per second square can be written as kilogram meter second negative 2. Then its dimensional formula is MLT negative 2. Force is a vector quantity. Why? Why force is a vector quantity like momentum? Because it is the product of scalar quantity and vector quantity, and the scalar times vector equal vector quantity. The second definition for Newton's second law said that the acquired acceleration to a body by a resultant force is directly proportional to the force and inversely proportional to the mass. The acquired acceleration to a body. When a force acts on a body, the body acquire an acceleration. The body gain an acceleration. This acceleration is directly to the force, means as the force increase, the acceleration increase, and the inversely proportional to the mass. Then, as the mass increases, it acquires or gains a small acceleration, and as the mass decreases, it acquires or gains large acceleration. Then the acceleration is directly proportional to the resultant force. This is the relation. And the acceleration is inversely proportional to the mass. This is the relation. Then totally acceleration is proportional to sigma f in the numerator and m in the denominator. Cross multiplication, then sigma f, the resultant force, equal mass times acceleration, the same relation. And the measuring unit is Newton. Then sigma f equal ma is the mathematical relation for Newton's second law. Newton is defined as, by the way, Newton, what is meant by 1 Newton? Newton is the force that when acts on a body of mass 1 kilogram, it accelerates it by acceleration 1 meter per second square. By the way, again, 1 Newton means Newton is the resultant force that when acts on a body of mass 1 kilogram, it will accelerate it by acceleration equal 1 meter per second square. Yibqa Newton is the force that acts on a body of mass 1 kilogram to accelerate it by 1 meter per second square. To compare the force act on two different bodies, when the same force act on two different bodies, then m1 divided m2 equal a2 divided by a1, like the momentum. Or we can write it by linear equation, m1 a1 equal m2 a2. This is the another way to write this equation. Example. A force act on two bodies. The first of mass 10 kilogram to accelerate it by 2 meter per second square, and the second of mass m to accelerate it by 5 meter per second square. Find m, the second mass. By using the previous relation, m1 divided m2 equal a2 divided a1. يبقى 10 divided by m equal 5 divided by 2, cross multiplication, then the missing mass equal 10 times 2 divided by 5 equal 4 kilogram. The second point is Newton's second law, where in sigma f equal mass times acceleration, and this is the resultant force of more different forces that act on an object. From the first term, we studied that the resultant force can be determined from the following relation, where a force of direction or in the direction x and the force in the direction y, then the resultant force from the middle equal square root fx power 2 plus fy power of 2 by Pythagoras. Then let's study this example. In the following figure, find the resultant force. We notice that the force in the direction x is 4 Newton and the force in the direction y is 3 Newton. To find the resultant force, let's move the force in the y direction in the other side to complete a right angle triangle bisectors, then sigma f equals square root f 4 power of 2 plus 3 power of 2 equal 5 Newton. Another example from the figure, find the acceleration. If a body acted by 4 different forces, then each 2 forces in opposite direction can be subtracted from each other. Each 2 forces in the opposite direction can be subtracted from each other. And we notice that the mass, are given that the mass equal 5 kilogram. Then 20 minus 8 equal 12 Newton. 11 minus 2 equal 9 Newton. Then to find the resultant force for the body of mass 5 kilogram, then sigma f equal bisectors 12 power 2 plus 9 power 2 equal 15 Newton. This 15 Newton at the resultant force equal mass times acceleration. 15 equal, the mass equal 5 times the acceleration. Let's put the 5 in the denominator on the other side. Then acceleration equal 15 divided by 5 equals 3 meter per second square. When a body moves in a horizontal surface, touching the floor under the effect of different forces, like this car, the car is moving by acting force, the force of the motor or of the engine, and the friction force between the car wheels and the road. Then the total moving force of the car is called the resultant force. Then the resultant force equal F moving, that is equal to acting force minus the friction force. This is an important relation. Sigma F, the total resultant force, equal the moving force of the car, by which the car is moving, that is equal to the acting force by the motor or the engine minus the friction force. This to study this example. A car of mass 500 kilogram is moving in a straight line with acceleration 3 meters per second square, where the thrust force of the motor, the acting force of the motor, acting on the car is 1200 Newton. Then the friction force. Find the friction force. Since the moving force, that is equal to MA equal F acting minus F friction. Then the mass is 500 times the acceleration equals 3 equal the acting force of the motor or the thrust force equal 1200 minus the friction force. Then move 1200 in the other side by negative sign. Then the friction force equal 1200 minus 1500 minus 1200, that is equal to 300 Newton. This is the friction force that acts in the opposite direction of motion. By the end of this lesson, there is a comparison between mass and weight. Mass is the resistance of the body to the change in its kinematic state. Mass is the resistance of the body. When you try to push a body or an object, this body is opposed you by a resistance. Then the mass of the object is a resistance. As the mass of the body increase, the resistance of the body to your push increase. So the mass is the resistance of the body to the change in its kinematic state. While the weight is the force of gravity acting on an object, the force of gravity. Mass is measured by kilogram, unit of measuring. Weight, as it is the force, then weight is measured by Newton. Mass is a scalar quantity, has no direction. Weight has a direction downward, so it is a vector quantity. Mass is constant by changing the body position, while the weight is variable. Weight is variable, while mass is constant. Mass equal F over m, while weight equal m times g. Mass times the gravity of the earth. Then, if the gravity of the earth equals 6 times the gravity on the surface of the moon, then the weight on the surface of the earth equals 6 times the weight on the surface of the moon. Let's read this example. If a body of mass 60 kilogram, find the weight of this body on the earth's surface, find the weight on the moon, find the mass on the moon. If g of earth equal 10 meters per second square. Weight on the surface of the earth equal mass times the gravity of the earth. 60 times 10 equals 600 Newton. The weight on the surface of the moon equals the weight on the surface of the earth divided by 6. Divided by 6. 600 divided by 6 equal 100 Newton. At the last, mass is constant. Doesn't it change? Equals 60 kilogram. Thank you. This is the end of the lesson.